Welcome to our webinar From Residue to Resource, Unlocking the Cellulose Potential, with the participation of Cornerstone, Wood to Wood and Resurgence projects. I will start by introducing one of our panelists, Sara Luciani from the ICARUS project. Sara holds a degree in industrial chemistry and is engaged in the fields of circular economy and sustainability. She is an R&D scientist at ICARUS, where she works on the development and optimization of absorbent hygiene products known as AHPs, recycling processes, and the valorisation of secondary raw materials, with a particular focus on cellulose. She is the ICARUS reference for the ICARUS project and a co-author of patents related to AHP recycling and cellulose valorization technologies, working closely with universities and research institutions. Thank you so much for being with us, Sara. Would you like to tell us a bit more about ICARUS?
Yes, thank you so much for organizing this webinar. I'll starting sharing my screen. Just a moment. Okay, so good morning, everyone. I'm Sara Luciani, R&D scientist from ICARUS Italia, and we lead Demo Case 2 within the ICARUS project. ICARUS is a Horizon Research and Innovation Action under the Processes for Planet Partnership. It is running from 2024 to 2027 and focused on upcycling large volumes of secondary raw materials. Here you can see our partners from the consortium. ICARUS brings together industrial partners, research centers, but also technology providers across Europe, for example, from Italy, from Spain, but also from France, Germany, Portugal. So ensuring both scientific excellence and industrial validation. ICARUS is fully aligned with the European Circular Economy Action Plan and the ambition of climate neutrality by 2050. And today, only a small fraction of global materials is effectively upcycled. So there is an urgent need for scalable circular solutions. It is important to highlight that the construction sector plays a key role in this transition because it consumes large amounts of raw materials and subsequently generates significant emissions. And so improving material efficiency here can have for sure a strong environmental impact. ICARUS contributes by transforming high volume waste streams into high quality secondary raw materials, specifically for the construction and ceramic industries, supporting both circularity and industrial development. Basically, our main objective within the ICARUS project is to develop and demonstrate innovative technologies that upgrade secondary raw materials to primary quality standards, making them suitable for new industrial use. And the targeted waste stream within the project are lithium aluminosilicate residue, waste cellulose, and steel-making slugs. Here there are some project key activities. The project integrates, of course, separation and upcycling technologies, as well as quality assurance tools, an LCA and LCC assessment, but also digital tools and, of course, stakeholder engagement to ensure real market uptake. These are our work package. Basically, ICARUS is structured around three demonstration cases. So the demo case 1 with the work package 7, then demo case 2 with the WP8, and then demo case 3 with the WP9. And each of them are supported by a specific work package focused on impact assessment, business modeling, and also dissemination and communication activities. So yes, here are our ICARUS demo cases. The demo cases addresses three major waste streams. More specifically, the demo case 1 is focusing on lithium aluminosilicate residues from lithium extraction. The demo case 2 is focusing on urban and industrial cellulosic waste. While demo case 3 is focusing on waste coming from steelmaking slags. Today, I will focus on demo case 2, dedicated, of course, to the cellulose recovery. But let's say, but why is cellulose so important? Cellulose basically plays, I would say, strategic and a key role in the European circular bioeconomy strategy, reducing waste, securing also secondary raw materials in order to reduce dependency on virgin cellulose, which nowadays is mostly imported from extra EU countries, and also supporting sustainable construction with the development and use of new low carbon construction materials. And so yes, this is our main goal within the demo case 2 of the ICARUS project. We focus on the recovery and upcycling of cellulose from two major waste streams, which are sludge from wastewater treatment plants and post-consumer absorbent hygiene products, also called AHP waste, which are basically diapers, nappies, and so on. These two streams represent a largely untapped source of secondary cellulose in Europe, with millions of tons potentially recoverable every year. But despite this, full-scale upcycling is still limited by complex processing routes or energy consumption or end of waste uncertainty and market acceptance and concerning related to contaminants. So within the project, our works aim to address these barriers and make cellulose-based secondary raw material safe and market ready. So in ICARUS, we want to improve recycling and upcycling technologies for recovered cellulose, and then the recovered cellulose will be recycled and upcycled into innovative product in concrete application in the construction sector through eco-design principles and sustainable processing technologies. To understand why this work is relevant, we need to look at how these waste streams are currently managed. For example, in wastewater treatment plants, cellulose mainly originates from toilet paper, and the potential recovery in Europe is estimated up to about 4 million tons per year. And currently, this material is degraded together with organic sludge. On the other hand, regarding absorbent hygiene products, around 30 million tons of waste are generated globally every year. Each ton contains approximately 225 kilograms of cellulose. Despite separate collection systems already active in several countries, for example in Italy, most of this material is still incinerated or landfilled. It is also remarkable that in Italy, in the Netherlands, and Belgium are already in place end of waste criteria for this specific waste. And finally, regarding cellulose fiber in concrete application, virgin cellulose fibers are already used nowadays in concrete applications. So in concrete formulation, because they help reducing, for example, dry shrink rate cracking, improving crack control and improving durability. And also this supports the reduction of synthetic fibers, for example, polypropylene in construction materials. We are currently halfway through the project duration, and we can already highlight some important results achieved so far. Firstly, we have installed a rotating belt filter at the San Celoni wastewater treatment plant in Spain, which is a specific filter able to selectively separate cellulosic sludge from total solid. And this system is operational now, and the first recovered sample have been tested with sanitization and upcycling tests with promising results so far. In parallel, in Italy, a demo plant for cellulose recovery from AHP waste has been installed and validated. The recycling technology has been successfully validated with the Italian end of waste decree criteria for this specific waste. And this is without doubt a key milestone for regulatory compliance and market uptake.
Sarah, very sorry, but we're running out of time.
Okay, I'll go quickly. Also, recovered cellulose from HP have already been preliminary analyzed with promising results. This is a quick overview of the HP recycling process with important step of drug elimination and sterilization step. And the same steps are for the cellulosic sludge, which is previously recovered in wastewater treatment plant for the rotating bed filter. The most important thing is that this dedicated treatment overall ensures that the recovered cellulose from both waste is safe, hygienic, and compliant with the end of waste decree criteria. And so looking ahead, our next steps focus on three main directions. We will continue, of course, the operation and optimization of the recovery systems, both for the wastewater treatment plant and at the HP demo facility. Second, we will further test different cellulose dosage in concrete formulation. And third, we will work on strengthening the regulatory framework, especially laying the foundation for promoting an end of waste decree for wastewater sludge as well. So to support wider market adoption across Europe. Yes, that's it. Here you can see our contact, also contact for the project coordinator, and thank you for your attention.
Thank you so much. Just a quick reminder, I will have to cut you after 10 minutes so we have more time for the Q&A. But thanks for the very insightful presentation. Now we move on to the Cornerstone project, and we have with us Cejna Anna Quist-Jensen. She is an associate professor at the Aalborg University, Denmark. She earned her PhD degree in 2016 from the Institute on Membrane Technology and University of Calabria, Italy. Her research focuses on novel membrane technologies for water and wastewater treatment, including resource recovery, membrane distillation, membrane-assisted crystallization, and 3D printed membranes. She currently coordinates 2 Horizon Europe projects, Cornerstone, addressing water, energy, and resource recovery from industrial waste streams, and Beyond Bad Rec, focusing on sustainable battery recycling. In addition, she contributes to several national and international projects on water and wastewater treatment. And she also serves as vice chair of the steering group for the AAU Water Initiative at Aalborg University. Cejna, we're so happy to have you. Would you like to tell us more about the Cornerstone project?
Yes, so I hope you can see my screen.
Yes, we can.
Yes, perfect. So yeah, I'm coordinating the Cornerstone project, and Cornerstone stands for Combined Technologies for Water, Energy, and Solute Recovery from Industrial Process Streams. So first, just some facts about the project. We are 16 partners from 8 different European countries, and it's coordinated by Aalborg University, where I'm from. And then the budget is around 10.5 million euros, and the duration is also 4 years. And we are a little bit more than midway now. We focus on different technologies, and I will tell you more about that during this presentation. But we have mainly 6 different technologies in 3 different case studies. And here you can see the list of partners and from which European countries they are from. But we are some large enterprises, some research and technology organization, some SMEs, and universities. So a quite broad range of different partners. And here you can see an overview of the Cornerstone project. So it's the overall objective is to achieve long-term circular economy in the European industry through recycling and reusing of different resources from the industrial process and wastewater streams. So we have different components involved in the Cornerstone project. The first component is different technologies, and here we focus on nanofiltration, heat exchangers, electrodialysis, membrane distillation, membrane bioreactor, and membrane crystallization. So some quite well-known technologies and some more newer technologies. And then we also have a component on digitalization, where we implement sensors and smart monitoring that we then optimize and control with AI. And we also do digital twins of the existing processes in 2 case studies, but also digital twins of when we implement the Cornerstone systems into these process industries. And the industries that we are focusing on is the steel industry, the pulp and paper industry, and the chemical industry. And I will focus today more on the pulp and paper industry later on in the presentation. But then we also have some transversal strategies as the fourth component, where we do some sustainability assessments like LCAs. We also do some exploitation toolboxes like decision support tools. How do we actually take the decision on how to best recycle water, energy, and solutes from the waste streams, and then of course also a part on communication and dissemination. And here you can see more detail about the objectives. So what we do is to test these different technologies, treatment modules in lab scale, using the real process streams coming from the industries. And then we integrate these technologies with smart monitoring tools and sensors to be able to control and digitalize the processes. And then what we are doing right now is to scale these processes up. So integrate the different technologies, integrate them also with the smart monitoring, then scale the technologies up and demonstrate it at 3 different demonstration sites in the steel, pulp and paper, and the chemical industry. And then, as I also mentioned before, we do the sustainability of our cornerstone solution, both focusing, of course, on the environmental impact, the economic impact, and also the social dimensions. And then we develop these decision support tools so we can enable like industrial water, energy, and resource stewardship. So it's very important in the Cornerstone project that we look at all these 3 in parallel to see what makes most sense. And here you can see a little bit more details about the different technologies. So for energy, we focus on 2 technologies. It's heat exchangers for the thermal heat recovery, and then anaerobic membrane reactors for chemical energy recovery. So for example, to produce biogas. And then for water recovery, focus on nanofiltration and membrane distillation. And for solute recovery, we focus on bipolar electrodialysis for acid-base recovery, and then membrane crystallization to recover some of the metals or minerals in the process streams. And as I mentioned before, we have 3 different case studies. So the first case studies is the chemical industry, and here we have a company called Covestro that in our project is located in Germany. And here our focus is chemical energy and water recovery. And then we also have the steel industry involved, and this company is HKM, also located in Germany. And here we focus on the thermal energy, water and acid recovery. And the last one, the pulp and paper industry, where our company is Essity, and the Essity part that we are collaborating with is located in France. And here we also focus on thermal energy, water, acid, and also to recover minerals from their process streams. And here it's mainly sulfate compounds. And a little bit about the digitalization part again. So as I mentioned, we integrate these smart monitoring technologies and sensors to optimize the processes and develop the digital twin. So it's also easier for us to implement it and see what, if we change something, what will the causes be, or test different things instead of testing in lab. And then of course we validate this using real data, both in lab scale but also at the pilot scale. And another very interesting part of the Cornerstone project is these decision support tools. So how do we actually also take the decision on a management level whether we should take one decision over another and so on. So there has also been a lot of work in talking to industries, not only the industries that are in the Cornerstone project, but also in general other process industries and other industries, to see how do we enable this water, energy, and resource stewardship. Yeah.
Cezna, you have 2 minutes left.
Okay, I will just be very fast. So just to focus a little bit about what we do in the pulp and paper industry. So here we focus on all different technologies for energy recovery, water recovery, and solute recovery. And yeah, so we have the non-clogging heat exchanger where we use ultrasound to optimize the heat exchange. And then nanofiltration, because with nanofiltration we can separate bivalent ions from monovalent ions, and with that it's easier for us to recover some of the valuable resources in the feed. We focus on membrane distillation, which is a thermal driven process. So here we can use waste heat to drive this process, and we also obtain very good results where we have more than 80% clean water recovered from the process. We use this bipolar electrodialysis where we can also obtain very high sodium hydroxide and HCl recovery rates from the process. And then as a last process, we have membrane crystallization where we can obtain more than 94% very pure water. And at the same time, we can obtain different minerals, mainly calcium sulfate, but also some calcium carbonate compounds. And here you can see a picture of some of the crystals. And then the last slides, we are now integrating these processes and upscaling them to demonstrate them at the actual pulp and paper industry. So we both produce clean water, minerals, and also acids and bases. So that is the idea for the pulp and paper industry. And then of course the heat exchanger to recover the thermal heat that we can then use to operate these membrane distillation and membrane crystallization technologies. And then that was the last slide. Sorry if I took a bit more time, but of course, please feel free to reach out to us. Here is my email, and this is the QR for the Cornerstone project or the website.
Thank you so much, Cezna. I think that was perfect timing. And just a quick reminder for the participants that you can pop your questions in the Q&A about this very interesting work our panelists are doing. And now we move on to wood projects, to Akrivi Korba. Quick introduction. She is a chemical engineer and researcher at the iSense group of the Institute of Communication and Computer Systems at the National Technical University of Athens. She obtained her master's in chemical and bioprocess engineering from the University of Groningen. She serves as the day-to-day project manager of the Horizon Europe Wood project, focusing on the circular valorization of wood waste and the recovery of cellulose for high-value bio-based applications. Her work lies at the intersection of circular economy, life cycle thinking, and advanced waste sorting and valorization technologies. Thanks very much for being with us today. Could you tell us about the Wood projects?
Good morning, everyone, and thank you for having me here to present you Wood project. Let me pop up my screen. Can you see my screen? So I'm going to present you very briefly the concept of the project and some interesting results we have currently in terms of cellulose valorization. Of course, initially some project facts. some facts about the call, the topic. Of course, the granting authority is the European Health and Digital Executive Agency. In ICCRs, we are the project coordinators of the project, and the project started the 1st of January 2024, and it will last 4 years. And at the bottom of the slide, you can see a QR code that if you scan, you can directly go to the project website and learn more information about it. Here is the logos of the all organizations that are participating in the Wood2Wood consortium. There are many big companies, industry partners, research organizations, universities, and a think tank, CEPS. And a little bit about the concept and what actually Wood2Wood is about. And before I start presenting you the project concept, I will tell you a little bit about the incentive. So why Wood2Wood and why we wanted to tackle this thematic. Of course, this was the huge amount of construction demolition waste that remains untapped and is not reused or recycled. So in Europe, this waste stream is containing 20 to 30% of materials like wood, making it a key focus of EU waste policy. So our main focus is Wood2Wood is actually to transform the contaminated wood waste from construction demolition waste and furniture waste into high valuable products. And how we are doing this? We have 4 main pillars of the project. The first one is the advanced sorting technologies that we will use in order to separate the wood out of construction demolition waste and furniture waste. The second one is the upcycling technologies that we are using in order to transform this wood into valuable products again. Of course, we have some digital tools in order to facilitate the circular flows of the products in this value chain. And of course, a supportive framework in terms of policies, markets, and skills. The 4 pillars of the project can be better seen in the next slide. Where you can see a schematic representation of the project concept. You see that we start from construction demolition waste, furniture waste. The first pillar is the sorting and separation technology, separating the wood initially out of the glass and other materials that can be present. And in the second phase, in several wood classes based on the contamination level of the wood. And based on this, we will use some upcycling technologies in order to transform the recovered wood into biocomposite materials, polyols, and some surfactants for chemical detergent and self-care products. You can see also the 2 supportive pillars. The first one, which is the digital tools, in order to facilitate the flows of the materials, and of course, the supportive framework for policies and market and skills. In the next slide, you can see the project objectives. Between those, to produce a comprehensive framework for wood valorization in Europe, to increase the separation capabilities and sorting mechanisms of wood, and of course, to develop technologies for upcycling these materials. Of course, we also want to develop digital tools for life cycle sustainability assessment, and of course, validate all of those in the project 3 use cases. And to increase competitiveness and promote sustainable practices in industries in general. We are now in the third phase. We separate the project in 4 phases. We are now halfway there, so we are in the third phase of the project, where all technologies are about to reach TRL6. And of course, after this, what comes after is the validation of all the products and technologies developed during this phase.
Akrivi, you got 5 minutes.
Thank you very much. Here you can see a brief overview of the project use cases. The first 2 are related directly to cellulose valorization. This is why I will describe in detail right after. And the third one is about energy recovery and actually use gasification processes and use the CO2 for the production of some surfactants for healthcare products and for some detergents. The other 2 I will get in details in the next slides, and they are directly about cellulose valorization. So in the first pilot and the first use case of this project, we start from wood waste, and we actually take the lignocellulose biomass, and we separate the cellulose, the hemicellulose, and the lignin, and we produce some nanofibers, and we combine these nanofibers with PLA. We do extrusion, and through 3D printing, we are actually preparing some biocomposite materials. These biocomposite materials can be used in wood facades. So we would like to validate their performance in these kinds of applications. In the next slide, you can see it's a little bit about chemistry and the process we use in this pilot in order to extract specifically the cellulose. But I won't get in details about that. I will get to the second use case, where again starting with wood waste and different types of wood. We do processes like steam explosion in order to get the glues and the paints out of the wood waste, and some microremediation processes. So using these processes, we get clean wood fibers that again we use for the production of microcomposite materials and some wood panels. We are also, in the same use case, we are also producing some polyols through liquefaction process that can be used for the production of non-isocyanate polyurethanes. And some results already we have in terms of cellulose valorization. In the first pilot, we already have the first biocomposite material, which is a honeycomb panel. And this is how it looks like right now. And we have 3 different combinations, 3 different panels to test. And we are now in the process of validating the performance of these panels in wood facades. Here in this slide, you can see the second pilot. In the second picture, you can see the steam explosion setup and the materials we get right after, which is clean wood fibers. And how we use these fibers in order to get particle boards. So here you can see the first particle board we have created from the steam explosion, the fibers, and we combined it with some glues that we also produced in this use case. And last but not least, I would like to refer to the advanced sorting and classification system that we are developing in ICCS in our premises. in order to increase the amount of wood waste and the wood that we recover. I will show you a short video how this is working. You can see here that we have several sensors and robots in order to separate the wood in classes and in terms of contamination. So here you can see the big conveyor belt. And here are some robots, some Delta robots for the actual sorting of the wood. And also, probably now you will see some wood panels that they are passing through. These are the sensors that we will use for sensing foreign materials on the wood. These are the cameras. That they are sensing the wood and several objects that are on the conveyor belt. And based on the input, the robots are separating the wood into classes. And this is a schematic of the whole setup. And that was all from my side. Thank you very much.
Thank you so much for the very engaging presentation with the photos and the videos. We really enjoyed. So lastly, we have the Resurgence project, and we have with us Xuefei Yan. She is a researcher at the CITIM Technology Center, specializing in advanced membrane technologies within the area of the eco-biotechnologies. She has led several life projects and is currently the project leader of the Horizon Europe Resurgence. She holds a PhD in environmental engineering from the Polytechnic University of Catalonia, Spain. Thanks so much for joining us. Could you please tell us about the Resurgence?
Thank you, Susan, for the presentation. I'm going to share the screen. Could you see the presentation well?
Yes.
Yes. Well, first of all, I would like to thank the ICARUS project for the invitation. I'm Xuefei Yan. I'm from CITIM Technological Center from Spain, and I'm also the project leader of Resurgence. First, I would like to give a quick overview of who we are. Resurgence is a 48-month project kicking off in December 2023 with a budget around 10 million euros. Our consortium brings together 18 partners and 2 affiliated entities coordinated by us, CITIM. Our main objective is to help the transformation of European process industries into wastewater and resource recovery facilities, and that fully align with the Europeans' 2050 goals for climate neutrality, circularity, and competitiveness. To do this, we are integrating modular and flexible treatments with digital technologies. And we are recovering water, energy, and the valuable resources in our project. Well, our core strategic framework is what we call seeds of hubs for circularity. We can think of it as an ecosystem growing. First, we plant the seeds, which are the individual circular solutions, and these seeds then grow into pilots, which are integrated industrial systems where different solutions start to connect. And finally, these pilots mature into hubs for circularity with large-scale self-sustaining industrial and urban symbiosis. And our technologies are being validated in 4 real industrial case studies. The first one is Navigator, a pulp and paper industry located in Portugal. The second one is Organikimya, a chemical industry in Turkey. The third one is Cepsa, Poland, a steel industry. And the last one is an urban industrial symbiosis operated by Aquaria. And today we are going to focus on the first case study, pulp and paper industry. Well, here is a figure showing this case study. The inner circle represents the targets we aim to achieve with Resurgence technologies. The inner circle represents the targets we aim to achieve. The outer circle reflects the current state of wastewater management in the industry, highlighting areas in need of improvement. We will increase water recovery to up to 95%. Additionally, the recovery of different feedstocks, along with the conversion of sludge into biopolymers and biochar, will support the industry's goal of minimizing waste. And today we are going to focus on the cellulose recovery. Regarding the pulp and paper sludge valorization, the challenge is clear. The sector generates great quantities of sludge, and traditionally this is treated as waste, an expensive problem to dispose of. But if we look closely, this isn't just a waste, it's a complex mixture containing valuable biopolymers, including cellulose. So why focus on cellulose recovery? The sludge from pulp and paper industry, especially the primary sludge, is a treasure of carbohydrate content, largely in the form of high-quality cellulose fibers. And by recovering this, we are not just solving a problem of waste disposal, we are creating a new value stream. This recovered cellulose could be the starting point for a whole new range of bio-based products, from sustainable materials, bioplastics, to platform chemicals and fermentation substrates. So how do we efficiently and sustainably extract cellulose from the sludge? In Resurgence, our key technology is the use of ionic liquids. They are liquid salts at low temperatures below 100 degrees. They are composed entirely of ions, an organic cation, and an organic or inorganic anion. And what makes them effective and green for our application? Well, first, they have negligible vapor pressure, meaning they don't emit volatile organic compounds, and they are thermally stable, and importantly, their solvent properties can be designed by changing the combination of cation and anion. This allows us to design an ionic liquid that is highly selective for dissolving cellulose, leaving other compounds behind. Well, before we apply the ionic liquids, we needed to understand our starting material. In Resurgence, we worked with 2 types of sludges from our industrial partner. First, the sludge was dried and prepared, and then we characterized them. The results confirmed our target. The primary sludge is a rich source containing around 30% cellulose, and the biological sludge from the secondary treatment has a much lower cellulose content, only around 2%, which is as expected. And with our target identified, we are now in the process of selecting and testing the best ironic liquids for the job. We are evaluating two types of ironic liquids, a commercial one, and we are synthesizing another one in lab scale. And a critical part of our methodology is the entire process design. We are developing the extraction steps, but we are also focusing on what happens after extraction. We are testing limony, a bio-based solvent, as a green extractant to recover the cellulose from the ironic liquid. And importantly, we are designing every step with the final goal in mind to be able to recover and reuse the ironic liquid itself, making the whole process circular and economically viable. Well, by the end of this work, we are expecting to develop and prove tailored ionic liquids that can selectively recover over 80% of the cellulose from industrial sludge. And we will have demonstrated that these solvents can be effectively recovered and reapplied, making the process economical. And the direct results will demonstrate a great reduction in sludge disposal costs and the creation of a new high-value product stream. I think that's all for my presentation. Thank you very much. This is the contact information in Resurgence and also the project website if you want to know more information about us. Thank you.
Thank you so much, Xuefei, for the great presentation. I think we can move on to Q&A now. I would just like to remind our panelists that please keep your answers for a minute and a half, to give the floor to more questions. We have in the Q&A a question for Sara, I think. It's from Akio Yamamoto. It's about the economics for the cellulose recovered from WWTPs. Do you expect its production cost or market price to be lower than the current price of de-inked pulp?
Okay, so thank you for your question. That's actually a really relevant question. The inked pulp is mainly used in the paper industry, while our primary focus within ICARUS is on construction application, which have different performance requirements and different value chains. And so for this reason, I would say that a direct price comparison is quite complex, not directly straightforward. But however, in our at this stage of the process of the project, we are focusing on technical and process optimization, while a detailed economic assessment is foreseen in the next month within the project to evaluate overall competitiveness for a economic point of view.
Thanks so much, Sara. If there is any questions from the participants, please, you can also unmute yourself and ask. But in the meantime, I will ask a question to Cezna. Drawing from your experience working with industrial partners, what are the biggest misconceptions paper production companies might have about the cost benefit of investing in advanced recovery systems versus traditional wastewater treatment? And how does the Cornerstone demonstration help lower the risk of these investments?
Yes, thank you for the questions. I think, as I see it from my perspective, also as a researcher, I think in the past it has been very difficult to tell to the industry that they should make these investments to, instead of the conventional wastewater treatment, and invest in new technologies. But I think that there is a change in the way that the industries are seeing it now, also from a regulatory perspective, that it's not enough just to treat the water and the wastewater just for discharge, that there's actually a cost benefit in reusing not only water but also different materials, reusing the energy within the process stream. So I think actually also the partners that we have involved in Cornerstones are much more willing to try to test these things, and that is where Cornerstone and also other projects, and also the projects that we heard about today, really can help in this lowering the risk. So I think there is an openness to this.
Mm-hmm. Thank you. There's actually another question for you in the chat. It says, can you elaborate on the digital twins? What methodology and tools are used? How do you integrate calculations, simulations, and data acquisition? Is it manual or automated?
Yeah, so actually it's not me who's the expert on the digital twin part, but I can try to explain a little bit, and then also please reach out to me and I can take contact to the partners that are involved in the project. So we use different simulation tools that already exist. One is Simba, and then we integrate the different technologies into these digital twin. It's still some ongoing work that we are doing. I just have to see what if I can see and the data acquisition. So we also have a partner, Man and Hummel, who is taking care of the data collection. So we are using some box to collect the data, and that is where we have already some ready toolboxes that the different partners can just implement. Of course, there's already startups and issues of that, but then the partners could use the sensors that we had available to make the data acquisition. So that was something that we discussed a lot in the beginning of the project, but it's running quite smooth now. So now we have the data on lab scale, and will implement the same in our demonstration sites. I don't know if that is so. It's both. It's the data acquisition is automated, and but we also have the possibility to add manual data. But in the Cornerstone, it's automated, and then we will use those data to optimize.
Great, thanks very much. Maybe a question for Akrivi. What role can secondary wood streams play in improving the resilience of Europe's construction materials supply chain? Sorry, you're muted.
Thank you, Susan, for the question. I think they will play a significant role. First of all, in order to reduce the dependency we have now on virgin materials, and of course to increase the material availability this way. So in the way that we propose, the wood remains in the value chain and in use for longer. And of course, this also is very important for circular economy because we reduce also landfill, we reduce incineration. So the one is a dependency of on virgin materials and material availability, and the other one is the environmental purposes to reduce the landfill and incineration of wood and of waste. So I would put it in those two sectors, if I have to say. And of course, they will make them. I believe they will make the construction supply chains maybe more local, more stable, for sure less vulnerable.
Great. Actually, there's another question for you in the chat from Grigory Zinoviev. Sorry if I mispronounced your name. Are you planning to evaluate an opportunity to reuse the adhesives? Is there any negative effect of having adhesive residue after stream explosion on the wood binding?
Depends on the material. So steam explosion can effectively remove some type of adhesives and some types of materials, but of course not all of the materials can be removed through steam explosion. We will use also some microremediation processes for different adhesives and different coatings. But of course, this applies for specific materials. And of course, if there is a remaining adhesive in on the wood that is going to be valorized, of course, this is something we need to take into account for the valorization path. But this is something we are looking into in wood-to-wood framework. So we look into the contamination level of the wood, and based on this, we will do a classification. And based on the classification, we will try to find the optimum valorization path.
Great, thank you very much.
Thank you.
Now I'd like to actually move to Xuefei. You've stated there is still a gap between innovation development and real industrial application. We need efficient solutions to bridge these two sectors. How are the solutions being developed in the Resurgence project helping to bridge this gap?
Well, thank you for the question. Well, I think the gap between innovation and industrial applications often comes from the fact that technologies are being developed under controlled laboratory conditions, while industry operations often suffers changes. So in Resurgence, we try to reduce this gap mainly by working closely with industrial partners and using real wastewater streams from the beginning. This means that the technologies are not only optimized for performance, but also for operability and integration into the existing processes. And also, I think the gap is affected by the level of adoption by the industrial partners. So we are also doing LCA and LCC analysis, life cycle analysis, and the cost analysis together with digital tools. So the industries can understand not only whether a technology could work, but also what it means operationally and economically. So overall, the idea is to move step by step from innovation towards solutions by involving industries in every step.
Thank you very much. I see there's a question in the chat from Lame, I think. You say, my question is actually to all the presenters, but we don't see your question. Would you like us to unmute you so you can ask? Okay, here it is. What type of cellulose are targeting, or you just extract cellulose fibers and later convert it to other types of cellulose? This is for all of the speakers, so if anyone would want to go first.
I can go first.
Yes, sure.
In Wood to Wood, we have in the first pilot we have we specific have cellulose nanofibers. So we start from wood waste, and we separate lignin nanofibers, lignocellulose nanofibers, and cellulose nanofibers, and we combine all of those. They are provided to National and Technical University of Greece. They combine it with polylactic acid for the production of biocomposite materials. So this is exactly what we do, and we start from cellulose nanofibers. For the other pilot that we use, the steam explosion, we have wood fibers, but not actually separating somehow lignin from cellulose.
Maybe I can go.
Sure, thank you.
With my answers. Yes, our main objective within the ICARUS project is to recover cellulose fiber, let's say, as is. So with properties suitable for construction application. So we focus on maintaining the functional characteristic of the fibers during the recovery process, rather than transforming them into other types of maybe chemically modified cellulose. So basically the added value comes from application-specific validation rather than further chemical conversion. So we are not focusing on that further modification or derivatization reaction on cellulose.
Thanks very much. Cezna or Xuefei?
Yeah, actually in Cornerstone we do not focus that much on, or we don't focus on the cellulose, but it's more the recycling of the water and the minerals and also acids or bases. So we don't have the focus on the cellulose for recovery in Cornerstone. It was just to mention that.
Well, in Resurgence, as a sister project of Cornerstone, we're under the same call. The main focus is on water treatment along with resource recovery. Well, we are trying to extract cellulose fiber from pulp and paper sludge, but we are recovering it as it is. We are not doing further valorization of this cellulose fiber recovered to other forms. Thank you.
Thanks very much, all. I don't see any other question in the Q&A, so I think I'll go ahead and ask myself. Sara, so separation of nappy waste already exists in Italy, but often this waste still ends up in landfills. To scale this process and ensure a steady, high-quality feedstock for recovery, what kind of synergy do you expect between municipal collection systems and the new industrial capacity being built in Italy?
Okay, so thank you for your question. Yes, separate collection of diapers is already active actually in many areas of Italy. But the lack of treatment infrastructure limits, let's say, its effectiveness, often resulting in the material still ending up in landfills or incineration. this new industrial capacity currently being developed offers a real opportunity to valorize this waste stream, but establishing a stable synergy with municipal collection systems will be crucial. So this will require, for example, structured agreements between treatment companies or local utilities, public administration, as well also, of course, regulatory incentives to support separate collection and dedicated logistics. So the goal is to build a reliable entire value chain that ensures consistent feedstock quality and makes the recycling process economically viable.
All right, thank you so much. Going back to Cornerstone, Cezna, what are the main technical hurdles to integrating the recovered chemicals back into paper production while ensuring they meet the necessary quality standards for industrial operators?
But that is exactly and thank you for the question, it is exactly to deliver the right quality and quantity of the chemicals, and also if the water changes over time, to be able to make sure that we meet the standards for reuse. I think we can do that, and it's of course something that is in progress and something that we are also developing our technologies from this point of view, that despite of the input qualities of the feed stream, that we can deliver for example, the minerals in the right quality for reuse. So I think that is exactly the hurdle, is this with the quality and quantity, and how we ensure that this is correct with different analysis and so on.
That's good to know. Thank you. Xuefei, for the resurgence and within the sector, despite the existence of technically mature technologies, adoption is still slow. What are the main barriers to scaling up adoption, and how is the Resurgence project helping to de-risk these investments?
Okay, thank you for the question, Susan. I think the slow adoption is mainly because industries need certainty before modifying their existing operations. I think even technically validated solutions may introduce operational risks, require process adaptation, or have unclear economic return. And this naturally makes companies to have their concerns. And in Resurgence, we try to reduce this uncertainty by demonstrating technologies at pilot scale in real industrial conditions. And this allows our industrial partners to see actual performance instead of theoretical expectations. And as I mentioned before, the sustainability and economic assessment help quantify benefits such as resource saving or reduced waste management costs. And also the digital support tool with like a decision support tool will allow industries to evaluate different operational scenarios before investment.
Thanks so much. Thank you. Sara, I have another question. What are the biggest technical or regulatory hurdles in bringing upcycled AHP-derived cellulose to the market? And what factors will determine if it can be successfully integrated into established sectors and compete with virgin materials?
Okay, thank you, Susan. One of the main challenges in bringing upcycled cellulose from absorbent hygiene products to market actually lies in ensuring consistent material quality that meets the standards of industrial users. In Italy, for example, this is addressed by the National End of Waste Regulation, which is issued by the Ministry of Environment, and which clearly defines the quality parameters required for secondary raw materials from AHP's waste. So, but in addition, beyond this technical compliance, major regulatory and systemic challenge, let's say, is ensuring the extended producer responsibility, which is also called EPR. In that way, producers of diapers, nappies will take responsibility not only for the product design, but also for the end of life management of this material. So basically, to conclude, creating a stable supply chain from collection to recycling is essential to allow these secondary raw materials to compete with virgin one, with key success factors including a strong EPR enforcement, the industrial validation of recycled materials, and of course market incentives, or I would say obligations to use recycled content.
Thanks so much. We have now 3 minutes to left, actually. 3 minutes left, and I have one final question for the whole group, so whomever one would like to answer. So Europe's push to decarbonize is causing a rising demand for cellulose as a plastic alternative, while climate change and regulatory pressures are impacting our traditional forest supply. By unlocking these different hidden cellulose streams, you are creating a new urban and industrial source of materials, an alternative forest to meet these demands. If we are able to bridge the gap between innovations and real-world applications, how could this impact Europe's raw materials independence over the next decade?
Well, I could start.
Sure, yes, please.
Yes. Well, I think from my point of view, I see this recovered cellulose streams mainly as a complementary resource rather than a replacement for forests. And industrial urban residues already contain significant amount of cellulose that are currently under reused. So if we manage to scale these innovations mentioned in all these programs, I think Europe could diversify its material resources and reduce dependence on the virgin biomass. Thank you.
Definitely, thanks so much. Would anyone like to say a few words? Yes, Akrivi.
Yes, and in order to do so, on the top of, I totally agree with what Ife said, but and in order to do so, there are many factors that we need to look into, and this is also the cost competitiveness, the market acceptance. Also, we need to look into compatibility with existing production lines. And also one important thing in Europe is that for wood, for instance, they are not harmonized policy framework for the reuse of wood and the classification of wood. So each country have their own legislation, they have their own policies. So it's very difficult. There are a lot of things that we need to look into when we talk about and factors to check when we want to talk about replacement. And replacement is difficult. I believe the same, that it's more for enhancing and more supporting than replacing right now, at least, because of all of these factors and limitations.
Mm-hmm. Cezna or Sara, any final remarks?
I think
okay.
Cezna,
Sara.
maybe you.
Oh, okay.
Okay.
Sorry.
Sorry.
No, so I also really agree with the other presenters and speakers about it's a more supplement than might be replacement. Again, Cornerstone does not focus directly on the cellulose, so it's also just from my perspective what I think. But I think also in general for reuse, it's this policy and it's the legislation that is sometimes also the barrier for how much we can reuse. And I think actually the pulp and paper industry itself is actually one of the industries that leads the way here for recycling of materials. But it is really sometimes a huge barrier with these legislations, and how can we use resources and water and so on. So that is my
Thank you very
answer.
much. Thanks. Sara?
Yeah. Yes. For sure, unlocking these hidden cellulose streams, such as those from AHPs or wastewater treatment plant, for sure offers a strategic lever to reduce Europe's dependence on, for example, extra EU imports. And also, the numbers are actually really clear about it. So the numbers clearly show the scale of this opportunity, because, for example, only from wastewater treatment plant, we are talking about 4 million tons per year potentially recovered. And also considering HP waste, we are talking about only in Europe 8 million tons per year of this waste. So in a context where environmental and geopolitical pressures are making resource supply increasingly critical, this approach could significantly contribute to Europe's strategic autonomy. But it is also true that we need incentives and regulations that promote the development of new technologies that make these secondary raw materials competitive with the virgin one. So let's say that there's a good potential, but we need also some regulation that promote this step.
Thanks so much. So there's potential, we need regulation. I think that's a great closing for this panel. And now I thank everyone for joining us today and for the insightful remarks. I think it has been a really great panel.